Hi again guys, and now let's start lesson 2, which is nanotechnology and chemistry. Firstly, we have the measuring unit and we have prefixes which is added to the measuring unit to maximize or minimize this measuring unit. For example, if we have meter, we have centimeter, millimeter, nanometer, micrometer, and so on for minimizing the measuring unit. And also we have to add prefixes such as kilometer, megameter, gigameter, terameter to maximize this measuring unit. These prefixes, each one has to maximize the measuring unit with a certain value. For example, the kilometer contains 1000 meter, which means 10 to the power 3 meters. Megameter equal 10 to the power 6 meter. Giga means 10 to the power 9. Tera means 10 to the power 12. Beta 10 to the power 15. Exa 10 to the power 18. And by the same way, we have to minimize the measuring unit. For example, decimeter equal 10 to the power negative 1 from the meter. Centi 10 to the power negative 2. Milli 10 to the power negative 3. Micro 10 to the power negative 6, nano 10 to the power negative 9, pico 10 to the power negative 12, femto 10 to the power negative 15, and atto negative 18. This lesson is concerned with the studying of nanotechnology. What do we mean by nanotechnology? Nanotechnology is the technology of tiny object concerned with the multiplication of matter on nanoscale to create a new and special and useful product. The concept nanotechnology consists of two words. The first one is nano, which is derived from the Greek word nanos, which means dwarf, and technology means the practical usage of knowledge in a certain field. Nanometer is the special measuring unit which is equal 1 billionth meter, which is equal to 10 to the power negative 9 of the meter. Millimeter equals 0.001 or 1 times 10 to the power negative 3 meters. Micrometer equal 1 to the power negative 6 from meter. For example, the diameter of sand granule equal 1 to the power negative 6 or 1 to the power 6 nanometers. The diameter of water molecule equals 0.3 nanometers. The diameter of atom ranges from 0.1 to 0.6 nanometers. Scientists discovered that some properties of a substance, such as color, solidity, flexibility, melting point, speed of the chemical reaction, etc., change in nanoscale, such as the properties known as the size-dependent properties, because they change the properties by changing the volume. The size-dependent properties, those are the properties that change by changing the matter of the size of the matter. Nanoscale, the scale on which the nano properties of a matter appears. It ranges from 1 to 100 nanometer. The size dependent properties, like for example the nanogold, the gold is known for the shiny yellow color, but when its size shrinks, its color changes. Scientists discovered that the nanogold has many colors, such as green, orange, and red, which differs according to the volume of nano size. Nanogold particles are used in the treatment of cancer. Example number 2, like nanocopper. The solidity of copper molecule increases when they begin to shrink from macroscale to nanoscale. Nanoparticles have extraordinary size-dependent properties due to the increase of the ratio between the surface area and the volume on the number of atoms. When the size of a substance shrinks, the ratio between the surface area and the volume increases. So, nanochemistry is one of nanosciences which deals with the chemical application of nanotechnology. Nanochemistry is concerned with the description, the study, and creation of substance on nanoscale, and the unique properties of the collecting atoms and molecules on nanoscale. Nanomaterials have lots of different shapes. like thin film, tubes, granules. All of them ranges from 1 nanometer to 100 nanometer, and they are classified into one-dimensional nanomaterials, like thin films, for example, which are used in bending grooves to protect them from corrosion and rusting, used for baking food products to protect them from pollution and damage. Nanowire, for example, are also an example for one-dimensional nanosubstances. Nanowires are used in manufacture of electric circuits and used in manufacture of nanofibers. Number two, two-dimensional nanosubstances, like carbon nanotubes. These carbon nanotubes, we have two types of them. The first one is single-walled carbon nanotube and multi-walled carbon nanotube. The properties of carbon nanotube. Number one, they are good conductor of heat and electricity, and the conductivity of carbon nanotube is better than the conductivity of copper. The thermal conductivity of carbon nanotube is better than the thermal conductivity of diamond. Number two, carbon nanotubes are stronger than steel due to the strong bond between their molecules. The nanotube of the size of hair and can carry the train. Number three, they can bond easily with protein. Because of this property, they can use in biological sensors. Number three, or the third type of the nanomaterials, which are three-dimensional nanosubstances, like nanoshell, which are used in the cancer treatment, and buckyball, which consists of 60 carbon atoms with the formula C60. What is the importance of buckyball? Scientists are working on using it to carry medicine inside the human body, as its hollow structure suits the molecule to the certain medicine, which prevented the occurrence of the reaction between the medicine and the molecule. Nano application. Number one, we can use nanotechnology in agriculture, for example, in finding bacteria in food product, in food preservation, improving the nutrients and insecticide and medicine for the plants, animals, and certain specifications. Number two, we can use nanotechnology in medicine for early diagnosis of diseases, photographic organs and tissues, and transporting of a medicine right to the infected part of the body, which improves the efficiency and decreases the side effects. Number four, creation of very tiny devices for dialysis, which are being transplanted inside the patient's body. Number four, creation of tiny robots, which remove the blood clots from the walls of arteries in human body. We can also use nanotechnology in energy field. For example, for the production of solar batteries. We can also use nanotechnology in industry. For example, for production of unseen nanoparticles, which give glass and ceramics auto-cleaning property. Also, we can use nanotechnology in production of nanomaterial, which purify the ultraviolet rays to improve anti-sun creams and cosmetics. Number three, improving baking technology using nanomaterials in the form of sprays and paintings, which form protective layers on the electronic devices to protect them from scratches. Number four, production of stain repellent clothes with auto-cleaning property. We can also use nanotechnology in communication. Number one, in the manufacture of nano-wireless devices, satellites, and mobile phones. Number two, shrinking of the size of transistors. Number three, the manufacture of electronic chips with high capacities. We can also use nanotechnology in environment to manufacture the nanofiber, which works on number one, purify the water and the air. Number two, water distillation. Number 3, solving the problem of nuclear wastes. Number 4, removing dangerous elements from the industrial waste. What are the effects of nanotechnology? Nanotechnology has negative effects, like for example, health effect. Nanoparticles can penetrate the cell of the lungs and skin in human and the cells of plants and animals, which may cause a health problem to them. Number 2 has a negative effect on the environment. So we have the negative environmental effects, like the dangers of tiny wastes resulted from nanotechnology can attach to air due to their tiny sizes, which make them able to penetrate both plants and animal cells, and they also affect the climate, water, soil, and air. The last negative effect, which are the social effects. It may worsen the problem of the social and economic equality between the humans. Finally, we have to revise some definitions, like for example, nanopollution. The pollution resulted from the substance and wastes produced by the nanotechnology. Number 2, nanotechnology itself. It is the technology of tiny object concerned with the matter on nanoscale to create the new special and useful products. After that, nanomaterials whose sizes ranges from 1 to 100 nanometers, which have the unique properties. After that, we have nanochemistry, one of nanosciences, which deal with the chemical applications of nanotechnology. The last one is nanopollution. The pollution resulted from the substance and wastes produced from nanotechnology. This is lesson 2, and thank you.